All right. So we have an exam on Wednesday, right? Exam on Wednesday. I most likely will not be here for the exam. I might have what we call a proctor, which is just someone who's going to come in here and just hand out the test and sit here and make sure everyone's being fair. So because of that, they're not going to check your cheat sheet, so you have to turn it in with your test, and then I'll check it. So be real careful on your cheat sheet that it's not something you can't use, right? Remember the cheat sheet: formula, steps, procedures, no worked out problems. So if I get your test and I see your cheat sheet and your cheat sheet has worked out problems, then it's going to be a huge penalty on the test. Like, you won't be able to pass. You'll start at like a 70 if you have a bad cheat sheet. Okay? Now, I put together a review. It's a 10-problem review. I thought about letting you work it out in class, but I think that the nature of this test coming up Wednesday, I think because of what it covers, I think I'm going to work it out. All right? And I'm sorry, if you prefer to work it on your own, then you can do that. After class or something, you can go try it again. I should have enough. Now, the problems on this review are straight out of the book. I just kind of picked them out of the chapter tests in the back, but I put them on paper so you have something to kind of walk around with. I also printed out a couple of graphs, just in case you don't have graph paper. Just take one of these. There's 4 blank graphs on each page, so just take a couple of those. You don't have to use this. I just thought I'd bring them anyway. Have what? Graph paper? I don't know. What do y'all want? Graph? Do you want me to include a graph for the problems that require it, like just have it on the test? I can do that. You can have the option. You can get okay. There we go. These girls over here stole it. All right. Day 15. I think we have 28 days. Seems like we're closer to the end than we actually are. All right. Is everyone okay with me working through this? I mean, is that all right? I don't want to kind of steal your thunder here, but yes. The textbook thing, as far as I know, starting in the fall, there's a set of courses that they're doing this with. I don't know I think it's like 15 different classes that they're going to do this with to start. I could be completely wrong there. That's what I think I remember hearing. So they're not going across the board, everyone right away. I'm hoping that that's like a pilot, and they're going to say, oh, wait, hold on, maybe we shouldn't do that. But history tells us that, you know, the ball is rolling. Okay, let's work through it. So there's 10 problems. Let's see how long this takes me to get through, all right? And keep in mind that you're going to be allowed to have a cheat sheet on this test. So let's also think about things that we might want to write down on the cheat sheet as we work through the problems. So first thing, solve this system of equations using the graphing method. So the graphing method meant that we just want to graph the lines and try and figure out what? Where they hit each other, right? The point where they hit each other. So let's start out by looking at y equals negative 2x minus 1. Now this line, if I want to graph it, the easiest way I think to graph this would be to use the slope-intercept form or technique. That's when we have a line that looks like y equals mx plus b, right? Isn't that exactly in that form? What's M for us here? -2. What's B? -1. So how do I use that to graph? How do I use that information to graph? B is -1. -2 is M. Right? What do I do first? Okay, so I start by using the B, right? The B is my y-intercept. The B is the y-intercept, not the x-intercept. I've seen this a few times with students. They accidentally use this -1 here, right? And they move on the x-axis to the left 1. That's not it. It's down 1 on the y. So I'm going to move down 1 unit on the y-axis to -1, and I will put a dot there. That is 1 point on my line. All I need is one other point. So now I use my slope. My slope is -2. -2 is the same as -2 divided by what? 1. So this is my rise over run. So what does it mean to say that I rise by -2? That means I actually go down by 2. And then the 1 on the bottom means I move left or right? Right by 1. So I'm going to go from this point, right? From this point down 2 into the right 1. So down 2. That puts me at -3, doesn't it? And to the right 1. So I move down 2, 1, 2, and to the right 1. And that puts me about here. Y'all with me? And we draw a line through that, through those 2 points, to the best of our ability. Okay, that's just the first one, right? Right? Now let's look at the next line. We're still in the same problem. The next line was x plus 2y equals 4. Now for this line, I could solve for y, couldn't I? And do the same thing I just did. Or I could use the intercept method, which meant that we find the x-intercept, the y-intercept, plot the 2 points, draw a line, which is the way I'm going to do it. That way you've seen both, right? So how do I find the x-intercept here? Set y to 0, right? So if I set y to 0 in that equation, I get what? X is 4. Now, I also saw a lot of mistakes when I was going around helping people out on these problems. If x is 4, what is the point that I'm going to graph? 4, 0. Why is it 4, 0? Where is the 0 coming from here? Remember we set y equal to 0, right? So that's why it's 0 there. Questions? Draw a dot at 4, 0. Great, it's off my graph. I'm going to have to kind of wing it here. 2, 3, 4. 4, 0, so I'm here. Kind of way off to the right there. And what do I find now? I just found the x-intercept, the y-intercept, right? Y-intercept. To do that, I set x equal to 0. So if I set x to 0 in the equation, won't I just get 2y equals 4? Divide both sides by 2, you get y is 2. So what's the point that corresponds to the y-intercept here? 0, 2. Not 2, 0, 0, 2. Again, because we set x to 0, that's why x is 0 there. 2 comes from here. So 0, 2 means I just need to move up 2 on the y-axis and draw a dot. Crap. You see why I'm saying crap? I draw these, right, like this. And what's wrong? Well, they do hit, but not on my graph. My graph isn't big enough, right? Y'all see that? They hit somewhere over here, which means I'm going to have to redraw this whole thing, which is okay, all right? So let me come down. Let me go to a new page, and I will use some graph paper here. Maybe. Now, I only gave you enough to draw 4 graphs, but there are a lot more than that on this test. So, sorry, didn't print out a whole bunch of these. Okay, so let's go through this. Graphing method. Let's try this. Okay, my first line had a y-intercept of -1. I went down 2 to the right 1. And then I'm going to draw a straight line. The other one had a y-intercept of 2 and an x-intercept of 4, which would have been there. Now, if I could get a straight edge, I could try and draw the best straight lines I could possibly make and then see if I can tell where they hit. What's going to happen on the test if you get this problem and you solve it by substitution instead of graphing method? It's going to be counted wrong, right? You have to do the method that is being asked. Let's see if I can do this. It's not bad. I have a pretty good guess of what it is here. It looks like it's that point right there, doesn't it? This one? What does that look like to you? -2 and 3. Who else drew this pretty good and agrees with that? Yeah? So you'll have to eyeball this. You'll have to do your best. What I will promise you on the test is this, that the intersection point will be in nice numbers, all right? So it's not going to be like 1/2 and 0.7 or something crazy. They'll hit each other at nice integers. For this problem, I would provide you with a good graph to draw on, all right? Make sure you draw in pencil, though, okay? I mean, use a pencil. Don't use a pen on the test, because if you mess up, I'm not going to have extra stuff there for you. Okay, let's move on to 2. Okay, number 2, we have this system 3x minus 2y equals 23, x plus 5y equals -15. And I tell you to solve this using substitution. So again, I'm forcing you to do it a certain way. Forcing you to do something, even if you don't want to. It's kind of the theme these days, isn't it? Okay, so when you do substitution, you get to choose which equation, right? You get to choose either equation. You get to choose which variable you want to solve for. So which of these, bless you, which of these looks like the easiest equation and variable to solve for? Second equation, which variable? Do I remember this? It's been a long time. X in the second equation. Why? Because it doesn't have anything in front of it, right? It's just x by itself. So you make the choice here. You're going to solve equation 2 for x. You might need to go back in your notes and look over this method, all right? And figure out, I went through a bunch of these problems. So go back and review if you need to, if you forgot like how you choose which one. All right, so let's take the second equation. Let's just write it down. And let's get x by itself. So all I have to do there is what? Minus 5y on both sides. So essentially just move the 5y to the other side. When we do that, it becomes a -5y. What's still sitting on the right side? The -15 was still there, right? Okay, I have solved the second equation for x. Do you remember what to do now? Substitute, which is why we call it substitution. Substitute x equals this into what? The first equation, the one you didn't choose, right? So I'm going to substitute x equals negative 5y minus 15 into 3x minus 2y equals 23. So let's replace this x right here with negative 5y minus 15. So I'll have 3 negative 5y minus 15 minus 2y equals 23. Is that correct? Is that right? Exactly. Yes. That is not correct to write this way. You're going to get all messed up. That 3 in front of the x means times, right? So that means you have to have the entire thing that you plugged in, right, in parentheses. So that 3 will distribute. If you miss that, everything's going to get thrown off, all right? Questions on that step? Distribute through now, because now we have an equation that just has one variable in it. So we should be able to solve this for y. When I distribute through, I get negative 15y minus 45 minus 2y equals 23. Now combine like terms. Good. So negative 15y, take away 2y, that's negative 17y. I still have minus 45 equals 23. Now, add 45 to both sides. If I add 45 on the right side, what do I get? $68? Okay. And now maybe you don't know if 17 goes into 68 or not. My guess is it goes in like, I don't know, 4 times. Okay. But it would be negative 4, wouldn't it? Okay. So we have y equals, we divided both sides by negative 17, which gave us negative 4. So y equals negative 4. All right. Are we done? No, now we need to go find x, don't we? Yep, that's where I'm going with it, okay? I'm going to take that answer I just got. I'm going to go all the way back up to this one right there, where we had x, right? We said x was equal to negative 5y minus 15. So x equals negative 5. What was y? Negative 4 and then minus 15. Look at the way I wrote that. The y right here is a negative 4. That's going to multiply times a negative 5. That'll give me a positive 20, won't it? 20 minus 15 is 5. So x is 5. How do I write my answer? 5, negative 4. Hey, I went through all of the work that you've turned in, all the quizzes for attendance, everything. Your grades online should be up to date. Did anyone happen to get like a message saying that I updated grades? Okay, so some people you have it set to, you know, in Canvas you can change your settings, like anytime your grade changes, it'll alert you or something. Okay, I just want to make sure you did get that. So I have all your work up here. How do you want me to hand this back to you? Do you want me to just pass it around as a stack, or do you want to come up and get it after class? Pass it around? Is that all right? Okay, make sure there aren't any exams in here. Oh, no, that's a review. That's a key. Okay, just go through this stack and grab whatever you might have in there. All right, we're done with this problem, right? We're all done? This is the answer boxed up in the bottom right-hand corner. Okay, next problem. Solve this system by elimination. Okay, the idea behind elimination was that instead of drawing the lines and finding where they hit, and instead of solving one of them for one of the variables, what you did is you tried to kill off the x's or the y's. Remember that? Okay, so I think I'm going to go to try and kill off the x's. And the reason I'm doing that is because if I have a 2x on the top left here, if I just make that a negative 2x on the bottom, then when I add straight down, they go away. So that means I'm going to have to multiply what by what? Negative 2 on the second one, right? So that negative 2 will have to go through to all three terms there. I will rewrite my system. When I distribute through, I get negative 2x plus 4y, right, equals what? Negative 8. Now, what do? Add straight down, good. So add down, the x's are going to go away. We'll have nothing there. 3y and 4y add up to be 7y. We have our equal sign. And then what's 1? Add negative 8. Well, that's the same as 1 minus 8, right? Negative 7. So I really have 7y equals negative 7. If I divide both sides by 7, I get negative 1. So y is negative 1. Now, what? What do I do with that? Plug y is negative 1 into any of the equations that have x and y in it, right? So I'll just grab, how about I grab this first equation right up there? Just going to grab that one. 2x plus 3 times negative 1 must equal 1. So I replace my y in the first equation with negative 1 because I found that y was negative 1. So 2x, that'll become minus 3, won't it? Bless you, equals 1. Add 3 to both sides. Divide by 2 on both sides. X is 2. So my answer as an ordered pair is 2, negative 1. Okay? Problem number 4. We only have 40 minutes left. See if we can get through the rest of this in 40 minutes. I'm working through this a little bit fast because we've done all this before, but I'm recording it so that hopefully you will go back if you need to and watch it if you have to, all right? Joseph plans to invest $600,000 into 2 different accounts. One account should return 12% interest per year and the other about 4%. If he hopes to make $30,000 per year in interest from both accounts, then how much should he put into each one? So we did this. This had to do with banking, right? Remember, we talked about this banking. So let's see. What are they asking us to solve for? How much in each account, right? So let's define our variables x and y to be equal to, let's say, x is the amount of money in the account with 12% interest, And then Y will be the amount of money in the account with, what was the other interest rate here? 4. Now you may be saying to yourself, if there were two accounts, one with 12%, one with 4%, obviously you just put all your money in 12%, right? But this problem is supposed to be, he's like an investor, so there's risk involved. It might be the stock market. So this is what the expectation is, but it may not in reality be that way. Okay, so that just so you know, that's why it kind of doesn't make a lot of sense. Okay, all right. So let's see. Does anyone have a question on that? Okay, what's the first equation I know right off the bat? X plus Y must be what? 600,000. That's because, look, he started with 600,000, right? He puts a certain amount of money into one account and a certain to the other. By the way, I'll just show you this. Remember when we were doing the sweet tea mixture problem, right? This is basically the same thing, except you look at it as he has two accounts, right? He has the 12% and the 4%, and he's got $600,000 up here, and he's going to pour a certain amount into one and pour a certain amount into the other. And when you mix the rates together and how much he makes off each one, that should add up to be 30,000. It's the same exact principle, except with money instead of sugar. So I don't want you to look at these problems, these two word problems, as being completely different. They're very much connected. Okay, so the first thing is that. Now, the other thing is we know that the interest he makes needs to be how much? How much does he expect to make? 30,000. Well, 30,000 should be the interest he makes on the 12% account plus the interest he makes on the 4% account. So how do you figure that out? Okay, 0.12 times X. That's how much he'll make in interest off of the account with 12%. Yes. Then? 0.04, good. Now, remember everyone, we're converting all of our percentages to decimals by moving the decimal point 2 places to the left. Okay, 0.04 what? Y must equal 30,000. And that is your system of equations. Now, because time is an issue here, I'm going to work pretty quick now. I want to solve the system of equations by first removing these decimals. How do I remove decimals? Well, I move them, right? So I can move, to make this a 12, I move it 2 places to the right. To make this, let's see, a 4, 2 places to the right. So all of them have to go 2 places to the right. So this system will now become, I'll do it to the right over here. X plus Y equals 600,000. And then 12x plus 4y must equal, well, we had 30,000, didn't we? But we moved it 2 places to the right, so doesn't that make it 3 million? Every decimal point gets moved, so do not forget that that 30,000 now becomes 3 million. Questions? At this point, I do not tell you which way to solve it, so you're free to solve it however you want. So what would you like to do to solve this? Elimination? You want to kill the x's? Okay, to kill the x's off, you need a what up here? Negative 12, don't you? Negative 12 in front of that x. So I'm going to force the negative 12 in here and then distribute it through. Let me move down. I'll have a new system now when I move that, distribute that negative 12 through. It will be negative 12x, negative 12y. What is 600,000 times negative 12? So you have to use a calculator there. 7,200,000 or something like that? Negative. Is that what you get? Anybody agree? Anybody have a calculator? Y'all agree? Okay. All right. So then on the bottom I have 12x plus 4y equals, we still had not 6 million, 3 million here. And now we should be able to do what? Add down. The 12x's cancel. How many y's will I have? Negative 8, right? Negative 8y. And then if you take negative 7,200,000 and you add to it 3 million, you should get negative 4,200,000. You're allowed to use a calculator on the test, of course. And finally, divide both sides by negative 8. And what do you get? I'm sorry? 525,000. $525,000. And if that's what y is, how do I get x? Plug it back in, or think about it. Just think about it. How much money did he have to start with? 600,000. We just said y was 525,000, which only leaves how much left? 75,000. So either way, you could get x, 75,000. Now, that's correct as far as an answer. But because it's a word problem, I would hope that you would kind of explain what your answers mean a little bit here. The total result of this whole problem is this. Joseph should put $75,000 into the 12%, right? And 525,000 into the 4%. Right? Because wasn't X was how much we put in the 12%, wasn't it? And Y was how much we put in the 4%. So if we think about it as far as like investing money in the stock market and things like that, it's like he wants to take some risk. He might lose this money because it's volatile. So he only put 75,000 into that 12% potentially. And then the other is pretty safe bet, 4%. So he puts most of his money there. Questions? We have 30 minutes. I don't anticipate your test will be exactly this long, all right? But I wanted as a review to kind of give you a little more than what you would see on Wednesday. All right, number 5. Whole milk has 4% fat and low-fat milk has 1% fat. How much whole milk should be mixed with low-fat milk to make 60 gallons of 2% milk? So this is actually how they make 2% milk. They make whole milk, and then they make low-fat milk, and they mix them. So this is like this, right? Right here, the mixture. So let's define our x and our y. Let's let x be the amount of whole milk. We're mixing that with what? The low fat. So y will be the amount of low fat. What can you tell me about our first equation here? X plus y must be 60 because we need in the end to have 60 gallons, right? 60 gallons. So however much of the whole milk and however much of the low fat we mix together, at the end together, 60 gallons. Okay, now this is just like the interest rate, okay? The whole milk has what percentage of fat? 4%. So I know that the 4%, right, x plus the y, the low fat has what percent? 1%, so 0.01 y must equal, now you must be very careful here. This is where it's slightly different from the problem we just did. We want our final mixture to be what percent? 2%, but there's one more thing you need. Multiply it times what? 60, how much of it you have. In the last problem, we didn't have to do this. In the last problem, it was just, what, 30,000 or something like that? We didn't have to actually figure out this number. Here you do. Okay, that's our system. I'm actually going to multiply that 0.2 through real quick. 0.04x, 0.01y equals 0.02 times 60 should be 1.2. Is that right? 1.2. Yeah. Now what? Get rid of decimals on the second one by moving everything on the bottom equation 2 places to the right. So 4x plus y equals 120. So I just moved decimals on the second equation. How about elimination? You want to do elimination? What would you like to go after? The x's? Or you want to go after the y's? Yeah, what if we do -1 on the first equation? Won't that make that a -y right there? And it'll just cancel. Now, you could do -4 also. You're free to do, I mean, there's different, you have some choices here. Again, that seems to be the theme of the day. Choice. Choice is good. Freedom of choice is even better. All right, distribute through. -x minus y equals 60. -60. I just want to see if y'all are still there. 4x plus y equals 120. And add down now. 3x, y's canceled. 3x is 60. That means x is dividing both sides by 3. X is 20. Now you can plug that in, or just think about it again. It was gallons, right? So you need 60 gallons. That means y has to be what? 40. So in short, 20 gallons of 4%, or the whole milk, right? With 40 gallons low fat. If you do that, you will create 60 gallons of 2% milk. Notice the nice numbers. Right? The last problem, nice numbers. Any questions? Anybody else suffering with the allergies lately? Just me, huh? Just me. Figures. 6. Solve this, what? Linear inequality, right? You got to know what you're looking at here. You got to know what's expected. So this is a linear inequality. Linear inequalities, when we graph them, are not lines, right? They are what? The graph of a linear inequality in 2 variables is a shaded region of the plane, isn't it? But we start by graphing it as a line. And then we either make it a solid or dotted, and then we pick a test point and we shade one side. That all ring a bell? Okay, so let me first turn it into an equality, an equation. And since that is an equation, this is a line, right? How would you like to graph that line? We have two choices, right? We could do the intercept method or we can solve for y. What would you like, intercept or solve for y? You want to try and solve for y? All right, I'll solve for y. Won't that mean I need to move the x to the other side, which means I subtract it? Right, that just moved the x to the right. I'm looking for y equals mx plus b. Right now I have y over 2. How can I get rid of y over 2? Multiply both sides of the equation by 2, by the LCD. Couldn't you? So I'm clearing fractions really right now. 2y over 2. 2y over 2 is just y. But on the right side, you must distribute that 2 through the parentheses. So you'll get what? Negative 2x plus 4. Now this looks like our standard y equals mx plus b. So I'm going to go for my graph right now. Where do I start my graph? 4 units, right? Because I have a 4 here for my b. I go up 4 on the y-axis. 1, 2, 3, 4. I put a dot there. How do I get to another point on this line? I use my slope, which is negative 2 over 1. So I move down what? 2 to the right 1. Down 2, 1, 2 to the right 1. It puts me about here. And I'm going to draw a line through those, right? Should it be dotted or solid? Solid. Solid because we have, back up at the original problem, the inequality symbol had the little bar underneath the inequality. That bar means include the solid line. So I'm going to draw the solid line through here. And we're almost done. All we need now is a what? Test point. So I'm going to test a point. I'm going to test 0, 0. Now, what was the condition on our test point? We could pick any point as long as that point what? Wasn't on the line, right? So 0, 0 is obviously not on the line. So let's plug it in. And where am I plugging it into? The original inequality, not to the line, to the inequality. So let's see what I get here. X plus y over 2 greater than or equal to 2. If I plug in zeros, won't that just be 0 plus 0 is greater than or equal to 2? Is 0 bigger than 2? No. That means that this point that I picked, my test point, does not work, right? That point down here does not work, which means everything on the other side of the line does. So I just shade this side of the line like this. And I'm done. 20 minutes left. Questions? Does this seem like a lot of information? Yeah. It's all connected, though. I mean, in some way, shape, or form here, all of these problems are connected. They all turn out to be systems of equations or systems of inequalities, lines and things like that. So there is a common theme, at least. 7, solve this linear inequality. All right, let's try it. First thing we do, we recognize it's an inequality. That means when I draw it, it's going to be a shaded region of the plane. I'm going to have to draw a line. It's either going to be dotted or solid. In this case, I already know it's going to be what? Dotted, okay. Turn it into an equation. How would you like to graph that line? If you try x-intercepts and y-intercepts here, what would happen? You're going to get stuck. If you try and find the x-intercept, that means you set y to 0. If you set y equals 0, don't you get x is 0? Agreed? If I set y equal to 0 in that equation, then x must be 0. If I try and find the y-intercept, then I set x equal to 0, and then won't I get y is 0? So your x and y intercept are 0, 0. It's the origin. Is that enough for you to draw a line? Just 1 point? No. So that method actually fails here. So the only other thing would be to solve for y. Well, yeah, kind of. I'm not going to divide. I'm going to multiply by the reciprocal. So what I'm going to do, I'm going to try and get y by itself here. So I'm going to try and get rid of a negative 5 over 4 by multiplying both sides by negative 4 over 5. Negative 4 over 5, which is its reciprocal. What would happen if I do that? On the right side, negative 5 times negative 4 is positive 20. 4 times 5 is positive 20. You get a 1, don't you? A 1y, I should say. Or just y on the right. And on the left side, negative 4 fits x. Which, if you write it the other way around, becomes this. Doesn't it? We'll see that? Now, why do I like that? That looks like y equals mx plus b, doesn't it? Except what's b for us here? 0. So when I go to graph it, I know I start at 0, and then from there I just go what? Down 4 to the right 5. 1, 2, 3, 4. Right 5, 1, 2, 3, 4, 5. Dot. Draw a what? Dotted line. Oops. Now look at your test point. You cannot plug in 0, 0. Do you all see that? Since you cannot plug in 0, 0, you have to pick something else. 1, 1. Okay, that's fine. Let's test 1, 1. And we're plugging into the original inequality. So I'm plugging in, I should be looking at 1 is less than negative 5/4 times 1. That's the original problem, right? X is less than negative 5/4 y. Is that true or not? Is 1 smaller than a negative number? No. Where was 1, 1 in our graph? To the right, 1 up, 1. It was up here, right? We were testing that point right there. It did not work, which means we shade everything below the line. This. Okay, numbers 8 and 9, well, 8, 9, and 10 are all the same type of problems. So let's see how we get through this. Are there any questions, though? If you go back and you look at our first exam, you know, you'll probably realize that at the beginning we kind of started, the expectation was a certain level. The second exam, it went up a little more. This exam, I think you can kind of maybe see, it's not that I'm asking you hard stuff. I'm asking you to be able to do more in less time, which means that you have to be able to accelerate your thinking process, which means you have to be able to come in here prepared and know, okay, when I see this, this is what I do. And that's where your cheat sheet comes in. So make sure that you go through this again. Don't just watch me today and be like, got it. I'll be fine. At least review this one more time on your own. Sit down with this, see how long it takes you to do it without any help. All right. Next thing, number 8. We have a system of linear inequalities again. The basic idea behind a system of linear inequalities is that you first look at it as a system of equations, and you draw them, figure out where they hit each other, and then it's just a matter of shading parts of, which of the region corresponds to both lines, where they overlap is what I'm trying to say. So the way we did this last class is, well, actually, I don't remember the order we went in, so let me just go back real quick and look at this. This was day 14. So what did we do here? So we treated it, we turned it into an equation first, we solved it, we got the point, then we graphed them, right? And then we shaded. Okay, we can do that. We'll do it the same way. All right, so the first thing I do is I turn this into a system of equations. (4x plus y equals 6). I'm going to use elimination to solve this. So I'm going to multiply the first equation by -1 to get rid of the y. I'm working fast here, all right? I don't expect that you will necessarily be able to keep up with this. Negative goes through, and then my other equation. I mean, keep up as far as writing down everything I'm writing down. Now I add straight down to get 3x, the y's cancel, equals 3, which means x is 1. Once I know what x is, I take it and I plug it back into any equation. So I'm going to plug it into the first one right here. And I should get then, if x plus y is 3 and x is 1, then subtracting 1 from both sides, y is 2. So that means I know that these hit each other at 1, 2, which will help me graph. Now I need to draw each line, don't I? I need to draw each line. That's where they intersect each other, which I will just make sure when I draw these things, I use that information. Okay. So now I'm going to let's grab this first equation right here. X plus y equals 3. Let's move the x to the other side. That's negative x plus 3. Why did I do that? That looks like slope-intercept, right? Y equals mx plus b. So you should be able to graph that pretty easily. Grab the other equation, and let's solve that one for y. So just move the 4x to the other side, becomes negative 4x plus 6. That, again, looks like y equals mx plus b. So I should be able to graph that, right? Okay, I am ready to draw a graph. So I'm going to go to a new page. Anyone still need this? Okay, here's my graph. Where did they hit each other? 1, 2. So I know they hit each other right there. The first line that I had was y equals negative x plus 3, right? Y equals negative x plus 3. So that means I move up 3 on the y-axis. 1, 2, 3. And negative x means down 1 to the right 1, doesn't it? Negative 1 is a slope. But didn't we say earlier if they both hit that point, that means I have to go through that point? I mean, that's where they hit each other, right, at 1, 2? So I could just draw this. Now, am I going to draw it dotted or solid? Dotted. Remember, the original inequality had less than 3. So dotted here. Dotted, 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 like that. Now, the other line was y equals negative 4x plus 6. That means I'm going to go to the y-axis and go up to 6, which is here. And then I'm going to go, what, down 4, 1, 2, 3, 4, and to the right 1. So they hit, you can see where they hit each other. Solid or dashed? Solid this time. And I think to the right, I'm going to write down the original system right here. X plus 4y less than 3. And it was 4x plus y less than or equal to 6. What do I need to do now? Test points, right? What's a good test point for both these lines? 0, 0. Let's test 0, 0. Let's do it into the first one. Test 0, 0 into this first one right here. And don't you get 0 plus 0 is less than 3? Is that true? Yes. Now, which one of these am I testing right now? The dotted one or the solid one? Dotted one, right? So I'm testing that, and 0, 0 worked, which means that everything on the bottom side of the blue dotted line works. So that's, oh, y'all like the arrows, didn't you? Okay, now let's test 0, 0 into the other one. What happens when we plug it into the other one? 0 plus 0 less than or equal to 6. Is that true? Yes. So it is arrows pointing to the left again. This. And what am I looking for as my answer? Yeah, there's 4 different regions, right? If you wanted to label them, you could label them like region, let's say 1, 2, 3, and 4, right? There's 4 different sections. And I'm looking for the section that the arrows point to it. So like in section 2, the blue points away from 2, so it's not there. In section 3, doesn't the green and the blue point away? In section 4, the blue points towards it, but the green points away from it. In section 1, the blue and the green point toward it. So my answer should be everything over here. Okay, I'm out of time, pretty much out of time. I don't have enough time to start another problem. So I've covered every type of problem you would see. All right, numbers 9 and 10 are pretty much the same. I will just warn you on numbers 9 and 10, if you do those on your own. On number 9, look at x's, x is less than or equal to negative 2. You first turn that into an equation, x equals negative 2. What is x equals negative 2? It's a vertical line. So it would look like, here's negative 2, it would look like a vertical line. Okay? And if you look at number 10, I have x is greater than 4, y is less than or equal to 2. If I turn this one, y equals 4, right? Sorry, y. If I turn that x equals 4, that's a vertical line. X is 4 is a vertical line. And then this one, y is less than or equal to 2, I turn that into an equation. What type of line is that? Y equals 2. Horizontal. Okay, everyone. Please study. I'm not going to see you again till next week, unless you come by my office for help. Please go through this review again. Get help if you need it. Attendance, let's see, who's not here? It'd be so easy that way, right? I'll just call you quickly. Just say here or whatever real quick, and let me turn off my video.